And now I'm going to maximize. Also, in Blackboard, let me look real quick just to make sure. Our lecture videos are up. And I already put lecture videos up for what we're doing today. So they're already everything's posted already, okay? So remember, if you didn't see something or you missed a class or you just want to just like go over stuff again, the lecture videos are always up, okay? And I usually post them the day of or like a day or two later, all right? All right, so here we go. Fun time, which is adding, subtracting fractions, obviously, with unlike denominators. Actually, here, we'll just do the first one. Let's do this one. 5/6 plus 5/6. So sometimes it's really good to take a step back and ask yourself, okay, what type of problem am I given? The numbers are fractions. What type of problem is an addition problem? So the first thing I need to ask myself, are my denominators the same? Maria G, what do you think? Are the denominators the same?
Yeah.
Perfect. So you write one denominator, and then you write 5 plus 5 in the numerator. There's a little step I always do. I always do that little step. Now, the only thing I got to worry about is the numerator. 5 plus 5 is 10. How are we looking so far, everyone? Pretty good? Now, Todd, before I circle my answer, before I submit my answer, there's always one question I need to ask myself when it comes to this result. What is that question? You're muted. I'm sorry.
Yeah. Simplified.
Is this simplified? Very good. Is this simplified? Now, there are many ways to do this, but you know me, I'm old school. I like to break numbers down. I want to figure out the prime factorizations of each of these. 10 is 2 times 5. 6 is 2 times 3. Now, can anybody tell me why I like to do this method? Can anybody tell me why I like to do this? Do it this way.
To simplify 10/6.
Yeah, but why do I prefer to write out the prime factorizations of each number? Like, why did I do this step right here? Because there's a lot of people that won't do it.
Because it's easier to write it down instead of doing it in your head.
What do you mean by write down? You're correct, Todd. But can you explain what that means? It's a very vague sentence you just gave me.
Show your work.
Okay. But that still doesn't explain why I chose to do this.
See what the numbers equal for 10. What two numbers would be equal to 10 and 6?
Okay. We're all knocking on a door, but nobody said it yet. What do you think, Amber?
Because you're gonna have to reduce you may have to reduce the fraction.
I may have to reduce the fraction, and I want to know what numbers or number do I need to reduce it with. What do we see right here?
2.
And what do you see right here underneath?
2.
And we know 2 over 2 equals what number?
1.
1.
So by me writing out the prime factorizations, I can see how far I need to reduce. See, a lot of us won't even do that. You'll just try to do it in your head. While that's effective, I don't think it's the best way. I like to write out the prime factorizations so I can see with my eyes, okay, I'm going to reduce this by 2. So I put 1 over 1. Now, that 5 and that 3, can I reduce that with anything? Yes or no?
No.
All right, so the answer's done. So 10 over 6 reduces down into 5 over 3. Okay? I teach the same class at 8 a.m. What's today, Wednesday?
Hump day.
Hump day. It is. Oh, thank God. Because I know Thursday and then Friday, I got 2 classes to teach, and that's it. So I feel good about that. Now, on Monday, we went over this method. And I had, there was like 4 or 5 students that honestly refused to do it this way. So then they did their homework. This morning, the one student goes, Mr. Float, thank you so much for teaching us that method. She goes, it was so much easier. I kept trying to do it in my head and I kept getting it wrong. So I watched your video and I started doing it your way. And after that, I didn't get one of them incorrect. And I'm like, and I go, what helped? And she goes, I can see what I'm trying to reduce with. And I was like, perfect. That's what this is all about. So let's try another problem. Right, Amber?
Right.
All right, we'll try another easy one like this, okay? So let's go 4/3 plus 11/3. Okay, 4/3 plus 11/3. Well, once again, we have 2 fractions. We're adding them, so I need to check the denominator. In this situation, it's the same. And that's the best case scenario for us. So I write one denominator, and then I'm going to write 4 plus 11 in the numerator. Now, I'm just going to add the numerator together. 4 plus 11 is 15. Okay? Now I stop right here and I ask myself, is this reduced? The easiest part, write out the prime factorization. 15 is 3 times 5. In my denominator, the number 3 is prime. That's it. Asthma, do you see any number in the numerator and the denominator that I can scratch out?
Yeah, number 3.
Okay, perfect. So I scratch out the 3's and I replace them with a number 1. So in reality, I have 1 times 5 in my numerator and 1 in my denominator. And that is equal to 5. Does that make sense, everyone? All right? You're going to see how this just, it helps just to get things organized. I think that's the hardest part about learning, just in general, is just keeping things organized. You're taking multiple classes. How do you keep everything in track? You got to get organized. Don't try to study the night before the test. Do a little bit every single day. I know you probably heard this thing. For every 1 hour in class, you're supposed to study 2 hours outside of class. You know what? I agree to a point. There's only so much time in the day. Many of you have families, work, do other things. You know, so it's really hard to manage your time. All I'm asking for my class math, just give me a half hour a night. Just do a couple problems every night. All right? If you need, I can help. All you got to do, ask. Okay? Let's do another problem now. Now we're going to get a little bit different, okay? 7/12 plus 5/8. Here's a situation now where we're adding 2 fractions. However, the denominators are different. Now, as soon as you notice denominators are different, we need to be thinking those 3 steps. Step 1, find the LCM. Step 2, build an equivalent fraction. Let me write out the word equivalent for the first time. You leaving? Okay, love you too. Have fun today. All right. And then step 3, we're going to rewrite and simplify. Okay, those are our 3 steps. Now, a long time ago, in a galaxy far, far away, you've learned You've learned how to do this. However, it was at least, and I'm sorry for this, but at least in my experience, it was all smushed together. Where what I'm doing is I'm just breaking it up. So step one, let's find the LCM. To do this, we need the prime factorizations of each number. So 12 is going to be 2 times 2 times 3. Now, if you're wondering how I got that, please look in the upper right-hand corner of your screen. I took 12 and I said, I want two numbers that multiply to get 12. How about 2 and 6? Now, 2 is prime, so I circle it. 6 is what we call a composite number, so it can be broken down further.
3 times 2.
2 times 3, or as Asma said, 3 times 2. But the key here is we broke it down into prime numbers. So that is how I got 2 times 2 times 3. I'm going to do this. I'm doing the same thing with the number 8. Number 8 is going to be 2 times 2 times 2. All right, how are we looking so far, everybody? Now, if I treat this as columns, watch what happens. My LCM is going to equal 2 times 2 times 2 times 3. In other words, I just wrote the numbers straight down in a column format, just straight down. Does that make sense, everyone? Therefore, my LCM is just a multiplication of those numbers. 2 times 2 times 2 is 8, and 8 times 3 is 24. So there's step one. Are we all on the same page? All right. Step two. We're going to build equivalent fractions. So I start with 7 over 12. My goal is to multiply 7 over 12 by another fraction so that I get 24 as my denominator. Does that make sense, everyone? Now, do me a favor. Put your pencils down and just watch. Because this, personally, I think is the coolest thing about doing this. And it makes it so easy. I want you to notice that right here is the prime factorization of 12. Does everybody agree with me on that? So if I go down into my LCM, watch what happens. I'm going to highlight the same exact numbers in my LCM. The only number that is not highlighted is that number 2 right there. So if I ask you, what do I have to multiply 7 over 12 by to get a new fraction where the denominator is 24? 2 over 2. It is staring you in the face. Now, don't write it down, just watch. 7 times 12 is 14. So there's my first equivalent fraction. Just watch. I'll let you write it down in a second, because I need to erase some stuff real quick. So just watch. Now I'm going to do the same thing with 5 over 8. I want to build an equivalent fraction so that my denominator is 24. Now watch, I'm going to do the same exact thing. Right here is the prime factorization of 8. If I come down into my LCM and highlight the same numbers, the only number that's not highlighted is 3. So I'm going to multiply this fraction by 3 over 3 because 8 times 3 is 24 and 5 times 3 is 15. Does everybody see how I did that? Now, remember back in the day when you were taught how to add fractions or subtract fractions with unlike denominators? Remember when they said you got to find a common denominator? And sometimes you had to sit there and think for like 20 minutes? You don't have to do that anymore, because you're doing it right here. You're finding that LCM and you're noticing, oh, I have 8, which is 2 times 2 times 2. The only number I don't have is that 3. So I'm going to multiply that 5 over 8 by 3 over 3. Does that make sense, everyone? Okay? Now go ahead and write this down. I'm going to clean this up on the left-hand side here. I don't know if you've noticed yet, but I really like teaching math. Just throwing it out there. I love math. All right, so I'll give you a minute to write that down, step 2. All right, step 3, rewrite and simplify. So I'm going to write 14 over 24 plus 15 over 24. Notice now my denominators are the same. So the only thing I'm really worried about is 14 plus 15. And 14 plus 15 is 29 over 24. And Todd, I'm going to come back to you because I already asked you this question twice, so I'm going to ask you one more time. Once I write 29 over 24, there's one more question I need to ask myself. And what is that question?
Can we simplify it?
Can we simplify it? Now, all the way back in section 2.5, and I'm going to just pull this over so you can see it. Here is a list of the first prime numbers less than 50. See, these are all prime numbers. What's this number right here?
29.
29. It's not even letting me highlight it. I just want to highlight the number, bro. All right, it's not letting me. But you can see the 29, correct? So, when we look at our fraction, our answer, 29 over 24, can that 29 be reduced?
Nope.
So, Todd, is 29 over 24 already in reduced form then?
Yes.
Absolutely. Good job. All right, how are we looking? All right, adding and subtracting fractions. Honestly, it's just tedious, okay? And I don't know about you, but I'd rather take an extra minute, 2 minutes, or even 3 minutes longer to do the problem like this versus doing the problem and then getting it wrong and then having to redo it all over again. You would actually spend more time doing it that way. Okay? Let's do another one together, and then I'm going to start letting you do them on your own. This time, let's do a subtraction problem, okay? How about 5/6 minus 3/4? Once again, I take a 30,000 foot view. What I mean by that is I'm just looking at the problem. I have a fraction minus a fraction. I don't even care what the numbers are yet. Like, that's how my mind works. I say, oh, what did you give me? Oh, you gave me a fraction minus a fraction. Okay, well, I need common denominators. 6 and 4, they're not the same. So, step 1, let's do this LCM. 6 breaks down into 2 times 3. 4 breaks down into 2 times 2. So my LCM is going to be 2 times 2 times 3, which happens to be a 12. Step 2, we're going to build equivalent fractions. So I rewrite 5 over 6. And I know I need to multiply that by a number so that I get 12 as a denominator. What is that number? And be specific. What is that number I need to multiply 5 over 6 by?
2.
2 over 2. Very good. So that's going to give me 10 over 12 as an equivalent fraction. I do the same thing for 3/4. So 3 over 4. What do I multiply 3 over 4 so that I get 12 as my denominator?
3.
Very good, Asma. 3 over 3. So that gives me 9 over 12. Step 3 is to rewrite and simplify if necessary. So 10 over 12 minus 9 over 12. Denominators are the same. So you're just worried about 10 minus 9. And what is 10 minus 9?
1.
1 over 12. How are we looking? I can't stress this enough. You're going to hear me say this like all day. Every single problem is done the same exact way. Every single one. Okay? Let's try another one. This time you're going to try it. Negative 9 over 20 plus 17 over 30. So I'm going to give you until like 10:30 to do this because it's 10:27 now. So 3-4 minutes should be enough. I'm gonna mute my mic. But if you need, ask a question. Mr. Flo, can you give me a hint in the right direction? Like, I'll help you. But I don't know if I don't know if you don't ask. So go ahead and try this out, please. Okay. We still working? It's okay if you are. Todd, did you get an answer?
Yes.
What did you get?
7/60.
7/60. Did anybody else get 7/60?
Yeah, me too.
All right, so it sounds like a lot of us did. Also sounds like a couple of us didn't. So, Todd, I'm just gonna write this off to the right hand side because I don't want to forget what your answer was. Let's do the problem. Step 1, lowest common multiple. So 20 is going to equal 2 times 2 times 5. 30 is going to be, what is that? 2 times 3 times 5?
Yep.
All right, so let me give myself a little bit of space here. All right, so my LCM, if I come straight down, will be 2 times 2 times 3 times 5, which is 60. All right, how are we looking so far, everybody? All right, step 2. Build equivalent fractions. So 9/20, I need to multiply by that, a number by that, so I get 60 as my denominator. And I'm going to do this again. I'm going to show you the highlighter again. 20 is right here. It's 2 times 2 times 5. Now, in my LCM, 2 times 2 times 5, it's already there. The only number that I didn't highlight is that 3. So this is going to be 3/3, which turns out to be 27/60. How are we looking so far? Okay. Now 17/30. Well, if I highlight this again, there we go. There's 30. The only number that I don't have highlighted in my LCM is 2. So this would be 2/2, which turns out to be 34/60. So my last step, step 3, is rewrite and simplify if necessary. So this is going to be negative 27/60, because remember, at the very beginning of the problem, that 9/20 was negative. So it's negative 27/60 plus 34/60. Denominators are the same. So I'm just going to write it out as one big numerator with 60 as my denominator. And then negative 27 plus 34 is definitely positive 7/60. Now that 7 is a prime number, so I know it can't be broken down any further. So 7/60 is my answer. How are we looking?
Teacher, in step 2.
I'm sorry?
In step 2, in the second step, why we delete the negative in front of the 9?
So the only thing I'm worried about in this step right here is just building an equivalent fraction. Asma, if you wanted to, you could put the negative there, but that just means the negative's there. All right, so I omitted it only because I just want to build the equivalent fraction. Does that make sense? Okay.
I have a question.
Go for it.
What makes like super specific numbers like 2 and 7 like prime? That's what I never understood.
All right, so prime numbers are numbers whose factors are only 1 and the number itself. So Zach, for example, if I write down a number 7, can you give me 2 numbers, and they got to be whole numbers. So give me 2 numbers that multiply to give me 7.
7 and 1.
Okay. Are there any other ones you can think of?
No.
Okay, now, How about the number 9? Give me two numbers that multiply to get 9.
3 and 3.
All right, but why didn't you say 1 times 9?
I don't know, because they're in.
See,
I could find it.
and there's the difference. But there's a difference right there. A prime number will only have the factors 1 and the number itself. 9 is a composite number, which means there are multiple sets of factors. So 3 times 3 or 1 times 9. Look at 12. 12 could be 1 times 12, 2 times 6, or 3 times 4. Does that make sense?
Yeah.
All right, so that's the difference between a prime number and a composite number. A prime number, it's only going to be 1 times that number. That's it. Okay?
Yeah, okay.
Now, in like real life applications, Zach, that prime number is huge. Because there's no ambiguity about it. Like if you say 5, I know 5 is 1 times 5 and that's it. And because of that, there's tons of things we can do. Like for example, you can actually write hidden messages in just numbers. But you got to make sure that those numbers are prime numbers. Because you don't want any ambiguity. So you use prime numbers to hide your message. And stuff like that. If you're interested, I can tell you all about that stuff after class. Not a big deal.
Cool.
All right?
Okay.
All right. Any other questions with how we did this problem? All right. Let's move on then. So give me 1 second here. Because what I want to do